Hi, welcome to the second example for binomial distributions. Okay, I hope you guys have watched the previous video where we talked about example 4 from the textbook. And I hope you guys by now are know the difference. You guys know the difference between binocdf and binopdf. So have your calculator, have your GDC ready. We will need to use it for this one. Okay. Now pause the video and understand the context of this problem, please. Okay, welcome back. Now, so this girl Anna, she's gonna shoot for 15 times, and so my n is equal to 15. The probability that she hits the target, so p is equal to 0.6. Find the probability that she hits the target more than 5, at most 10. Okay, so the probability that we have to find out, it's a little bit tricky. More than 5, let's put that in terms of math notations. At most 10, which means maximum 10, less than or equal to 10. So my x, my probability of x has to be, oh, sorry about that. My probability of the random variable, which is the number of times that I hit the target, has to be greater than 5 and less than or equal to 10. Okay, I want you guys to kind of pause the video and try to understand what I have set up here. Okay, so now let's continue. This is equal to the probability. Can I have 6? 6 is good, but what about 5? Not 5. So I can say probability of 6 plus probability of 7 plus probability of 8. Let me just list them all out. Plus probability of 9 plus probability of 10. Right. Okay, so this is what we have to find. So what we can do is we can individually use binopdf, and find their respective probabilities and just add them all up. Or we can do this. If you think about it, why don't we try to use binocdf? Binocdf will give us the probabilities all the way up to that value. Right? So for example, let's say today I do, I'm going to write this in red, and this is not part of your workings. Okay, this is something that you can think of it to yourself, or you can write it down on scrap paper. If I do binocdf, say from so the first value is the number of trials, that'll be 15, comma, and my probability is 0.6, and then comma, and let's say if I put all the way up to 10, this is the total sum of my my probabilities up to 10, correct? And that value is not going to be 1 because I'm doing this for 15 times. And right now, if I do this, I'm only looking at 10 times. Right? But anyways, binocdf with 15.6 and 10, that's going to give me p of 0 plus p of 1 plus 2 plus 3 all the way up to 10. Right? So I have p of 0, 0, p of 0 plus p of 1 plus 2 plus 3 plus 4 plus 5, so on and so forth. Dot, 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 dot. Plus, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of this, right? All of this. That's what this is going to give me. Right now, I only want this part. So let me just write this down for now. I think it's better for me to write this down. Okay. So plus P03 plus P04 plus P05 plus P06 plus 7 plus 8 plus 9 plus 10. This is what we have here. binocdf is this whole list, right? This 11 items we have here. But right now, I'm only interested in 6, 7, 8, 9, 10. So is there some way for me to subtract? So if I find the value of this, I subtract all of that in the front, the red part, then I'm done. So how do I write this 0, 1, 2, 3, 4, 5? That will be binocdf with pretty much the same setting, 15.6, but up to where? Up to 5. Does that make sense? Up to 5. Okay? Because we're talking about we must have something that's more than 5. So 5 cannot be it. If let's say to say more than or equal to 5, then if we have this greater than equal to, then the 5 cannot be there. Alright, so be careful with inequalities. Make sure you understand the context of the problem. So all you have to do now is to put this in your equation. Put this in your calculator. But how would you show the equation for this? Because you do have to show equations, your workings, even if it's a calculator paper, right? So how do you show workings for this? Wouldn't this be the probability of x is less than equal to 10? That is the whole thing. So P0, 1, 2, 3, 4, 5 until 10 minus probability of x is less than equal to 5. Right. So probability of x is less than equal to 5, that will be 0, 1, 2, 3, 4, 5. So this counts as your working, okay? That counts as your working. And now all you have to do is just put down your calculator. Let's figure all that. So go to second bars. You go to binocdf. Trials will be 15. This is 0.6. And the x value will be say 10. Now this is the first part. That's the top. Alright, this is only the top. Minus binocdf. Sorry about that. binocdf. Again 15, 0.6, and that will be 5. Click enter, and you'll get the final answer. 0.74. Let's run that up to 3SF. 0.749. And that's it. That's your answer. Okay, so I hope you guys see that binocdf can be used in a pretty creative way, sort of, right? Just make sure you be careful with your inequality signs, okay? Make sure you be careful with that. That's a very, very common mistake. All right? Okay, this is it for now. I'll see you guys in the next video. Bye-bye.